Hello, welcome to the Big Strategy Podcast. I'm your host and fellow strategist, Jeff Hyatt. This is your go-to spot for real talk with the masterminds of business strategy. It's about sharing stories, insights, and those little nuggets of wisdom to help you unlock big growth. Let's turn the key and spring into action.
Well, welcome everyone to this episode of the Big Strategy Podcast. I'm your host, Jeff Hyatt, and we're lucky today to be joined by James Muraca, who is the CTO of Enersponse, a demand response company that's using AI as a way to help companies manage their electrical usage and also help utilities to balance their load. So we're definitely looking forward to this conversation, as well as hearing about your entrepreneurial journey. James, I will give you the first ribbon for our first guest from Oz. So welcome.
Thank you. Thanks for having me.
Absolutely. So how the heck did an Aussie get caught up with a bunch of a U.S. startup on demand response? I usually the American utilities are things people are running away from, and I need to know what brought you towards this.
As the sunny beaches of California. So I started life as an engineer a number of years ago in Australia. I was working on medical products, and we had an opportunity to work on a small energy product. There was a thermostat for another company, Zen Ecosystems at the time. And all of our sales and marketing team was located in the US. So had the opportunity to move from engineering in Australia to the US for that company. And through that, I met our CEO for my current company, Enersponse, James McPhail, as CEO. And we got started through, nights, weekends, working on Enersponse and trying to take energy loads into market. So having experience with a thermostat, obviously controlling lots of heating and cooling, not just in homes, but in small commercial businesses. We're trying to put those into energy markets and seeing that there was a better way of doing things. And we doubled down on Enersponse at the time.
I love it. There's so much that kind of goes all the way back in the long tail of demand response. And we used to, I remember back in the late aughts when Boulder, Colorado was a big feature city as a smart grid city. And startups always talked about the wall of the building as kind of the dividing line between what was controlled by the owner of the building or the tenant or the resident, what have you, and then what was the utility's responsibility. But just for someone who's catching up, who's probably listening to this inside of four walls, what's the background? Like, why do we need energy response? I know my bills are high, but so what? Yeah. Like, what's the story?
So demand response is essentially shutting things down in a controlled manner. So when a utility, people are moving into an area, they're building homes, starting businesses, a utility needs to find ways to generate energy or supply those locations with power. And they can either spend money on building a power generation, coal plant, gas plant, solar, or they can find ways to save energy and make the best use of what they have. So demand response is on that save energy side. We go out as Enersponse, and contract customers. This could be supermarkets, retail stores. It could be large manufacturing, water districts, pumping loads, farms. We go and talk to all these different verticals and say, can you shut something down? Can you reduce something? Can you find a way to save? And it's not all the time. It's for an hour on a day on a peak summer hot period, or when something is very cold, in Texas, Hurricane Uri, the storm Uri comes across and shuts down the grid. Can you help out? And we then get paid by the utility, and then we pay the customers. We get a signal from the utility. We send a signal to the customer. And we work with the customers and utilities to try and, in a controlled manner, shut things down before we have to go to the drastic actions or blackouts and actually grid disruptions.
So when you say we, not Enersponse doing that, but we, the utility, having to take those drastic responses. And so you're sort of balancing that supply and demand in the short term to prevent the long-term disruption.
Yeah, so demand response can be right up to that emergency point, right before the hardcore blackouts. We as Enersponse will take signals from a utility, and it could be the utility sending us a message saying, please shut something down in a nice voluntary way. Or we could be taking price signals in as the electricity prices spike to normal, say $50 a megawatt hour. It could spike to $5,000 megawatt hour.
Mm-hmm.
The grid's really calling out from a price signal, we need help. And that's where we'll take that price, translate it to a curtailment measure for a customer, and through an automated API or other mechanism, actually, work with the customers to shut things down in a controlled manner. Nice.
So with all that being said, when I hear the word a utility sending a message, is that like Doug sitting at the desk just hitting the big red button, or Homer Simpson hitting the big red button? It seems like it's still a very analog process. Is that the case, or is that becoming more digital?
Depends on where you are in the country. So we try as hard as we can to automate things where it wasn't automated before, and that's sort of how we got really into Enersponse in the first place. We came from a background of controls, and when Internet of Things, IoT, was a real buzzword, and being able to connect different APIs from a utility side or from a customer side to actually curtail and shut things down. So what we do is 90-something% of our megawatts of our sites connected across our platform are actually automated. So we can receive an API message, from a utility that says from 2 to 4 p.m. tomorrow, please shut something down. So we'll take that one message from a utility and then send it to the 1,000 customers in that utility area and ask all of them to shut something down, which translates to adjust temperatures, shut down a manufacturing line, and so on. So on both sides, we take automation in and distribute it. Or it could be some utilities just have emails and text messages, and they're still sending text messages and emails out, which is important to inform your customers and people why things are happening. But we take those emails and turn them into automation at the other end through technology that we can use today.
Nice. Very nice. Well, that takes us back to kind of the beginning of all this. And with all of and this is a basic question to encourage you to kind of go deeper, but, this concept of like, if everyone's installing solar on their homes and we have, where we're drilling all this natural gas in America and we have all these power plants, et cetera, like, why is electricity still a problem?
Because everyone still wants more of it. I mean, we're on an AI podcast and going to get into AI, I guess, and everyone wants to chat to ChatGPT and all these other technologies, and it's the background behind that. There's more data centers going in. There's more people moving into an area in a country. There's, we're recording this today, a day or two after Spain and Portugal just had blackout for 24 hours, right? So there's inherent volatility because there's renewables that are only available at a certain time, and trying to balance that with batteries and other, in quotes, firm load that's been out there, coal and others. And demand response where we are is at that sweet spot of conveying high and low price signals to shut down and try and balance those volatile periods. And hopefully everyone wins with a sustainable grid along the way.
Well, you teased it, so let's dive into it. First of all, looking at this idea of we have all of this data, weather data, historical demand data, and I want to get into predictive, but just first of all the data leading up to this point in time. Why can't it be better addressed? What goes into that? What are the challenges, and how far has it come? Like, with all of this historical data, why can't we do a better job here, and what role is AI playing?
So I guess there's a couple points there. One is, we still need more data and more frequent data, better quality data. So where some utilities, in California, in Texas, in New York have smart meters installed and streaming data to us as a customer of that data for our customers. We're receiving that data. It could be as delayed as 6 hours. So the meter on the side of the building, it has to go through all these, different servers and get streamed up through different Wi-Fi technologies, wireless technologies, and ends up to us 6 hours later, or it could be 2 to 3 days later. And that's in the best case, right? I get a 15-minute snapshot of what a building was doing 3 days ago. There's a bunch of utilities that don't have this, and we're relying on installing real-time meters at sites, and then we have to foot that cost, or the customer has to. So there's one part which is how do we get better? It's better data and more frequent data coming from utilities in the first place. It's customers owning and having access to their data so that they can give it to third parties like us to make better predictions. But I guess there's also the macro part, right? There is still weather that fluctuates grid. There's still gas prices. The electricity prices is really dependent on the price of gas across the country. And then there's world events that influence that. So you can forecast as much as you can, and then, different macro events happen, or different, this summer is not as hot as it was last summer. So the grid was relatively stable, and we overbuilt relative to what we thought was going to be a nice storm. Yeah.
No, I appreciate you breaking that down, and the macro pieces are real. I imagine you're playing more in that customer data level. Is that right?
We go both, right? Because demand response is a very weather driven mechanism. It's very hot in summer. The temperatures in summer really drive high grid prices, high grid stress. People want their ACs on, or in winter things freeze over and people putting their heating on, right? So that's where weather really drives us as a business, and what we should and shouldn't be turning on, or when we should turn things on or off. So we still look at that often. And then based on program parameters, some programs allow us to enroll monthly. So it gives us the opportunity to test the customer this week and change what they were doing next week. Some programs have a year ahead plan. So we sort of looking at what do we think the weather's going to do in 6 months? What do we think the grid's going to do in 6 months? So different regulatory constructs would help us as well, or being more open to different customer types that have real-time access or real-time flexibility, and being able to take that data in faster and make faster dispatch decisions also helps us as well.
And is that the real value proposition, is that AI allows you to make those iterative decisions faster? Or is there more to it that AI or machine learning? And please help us clarify which technology is most prevalent in your solution or the industry, and how that's helping.
So for AI and machine learning, I guess internally we use both in different ways.
Right. Yeah. Tell us more.
So we use AI as a tool for development and so on, and maybe we'll get into that a little bit. We're exploring from where we've just gone for grid and forecasting. We've explored using AI as far as large language models for things like forecasting and so on, and it hasn't been as great as a tool compared to machine learning, where machine learning has allowed us to use moving average type models. Facebook Profit, AWS has a tool as well that we've been using, experimented with. But you can load in historical weather, customer square footage of their buildings, energy data, kilowatt information, future historical weather. You build up a model and a regression type model, and you can see historically what the up and down. I'm waving my hands in a sine wave type of view for the people on the podcast.
Thank you. Yes.
You can see the up and down of a weather fluctuation on a day or a month or a yearly period, and then see historically what they could have done. And then based on a 10-day weather forecast or a manufacturing schedule for a customer pumping station, or rainfall going into reservoirs for pumps and so on, you can start to forecast 10 days out, does this fit this model? And that starts to build up how much energy we could expect the customer to use and therefore save.
You touched on something really important, and this is, I think, overlooked a lot, especially by folks who don't have as much understanding of the technology. I think they just think AI is like some kind of fairy dust. You just sprinkle on whatever and it makes it better. But you said something really key that I want to touch on, that you found machine learning to be a better technology for your solution than artificial intelligence. And so even just taking a step back and help educating folks, like, I mean, one's a statistical model, and then you talk about linear regressions, and not to get too technical, but how are those different, and why is machine learning, which doesn't get as much press, actually better?
So where I've seen, I guess it's sort of, you just hit it there right on, a statistical model. We don't really know what a customer is going to do next week, right? We don't know if it's if a manufacturing facility stops working or so on, but we're pretty confident what they did last month or in the summer last year is probably going to be similar to what they do next week. So that's where those machine learning models, as you get closer and closer to real time or within a 10-day weather forecast, that's where you start to get a good correlation of what somebody could be doing in a nearer term. Where we've played around with AI and language models, we found them, I mean, at least I have, really useful for that blank template, that white paper when you sit down to write. It's a really useful for small known problems or give me a template. But once we start to get into really business specific edge cases at a larger view, we use things like Codium or other tools for Cursor and so on for writing code. It's great for those ingrained modules and, sort of business logic type of, once you break it down, that larger view, it still takes an expert or somebody to look over it to say, is this actually what the customer wants? Is this actually what I'm trying to get out of my system, or how do these things interact? There's still something that seems missing.
You touched on something that's near and dear to my heart, and that's the statement of like, is this what the customer wants? No customer wakes up in the morning saying they want more AI, but they do want lower energy bills, right? More predictable supply of electricity to keep their line going, et cetera. I took so many notes on what you just shared. I'm going to kind of unpack them. So just to kind of put my spin on it is, all LLMs are, as you said, statistical models and the distance between these vectors. That's all it is. And it doesn't understand the math that actually goes into calculating any sort of value. And whereas machine learning, using these algorithms that are rooted in mathematics, right? Like you said, like a regression model, for example, or a moving average model, that's actually more granular and a better predictor than what people might think of. So just for executives out there, that's one thing that I think is really important to understand, the difference between AI and machine learning, and understand which one's best for your business.
Yeah, at least, so although I'm Chief Technology Officer, I run our product teams. Although I'm a technical and engineering person, I still, the business has to, we don't build things just because it's fun to build, right? We want to use real proven technologies to solve an actual business need. And at the end of the day, we have to pay people and put food on table, right? So absolutely, it has to, no one wants more AI. They want, a constructive tool. So I guess from an executive perspective, I just said then it's within my mandate, it's my responsibility to make sure that we're up to date with what technologies are out there. But, I don't want to use the latest and greatest technology in our product stack all the time. In my dev teams, we'll explore those. I'll give it to one person to explore and give a lunch and learn presentation to the wider team. But at the end of the day, when I hit release to production, we need to make sure that thing works, right? That we receive a real-time event and within a minute we're shutting down heating cooling system at a Fortune 100 company, right? We need to make sure our data is secure and that we're not transferring things around that we shouldn't be. So absolutely experiment, keep up to date with technology, but always come back and use something proven.
That's a great segue into something you touched on earlier, the idea of using a program like Cursor or Lovable, whatever you mentioned, Cursor, in terms of just helping you map out these solutions in a very iterative way, but yet it's not ready for prime time. And then you just touched on the importance of your client's data. So there's a lot of like angles from AI I'm going to ask you about here. But the first one is just that trust. How do you build trust with your customers, knowing that some of their data is going to have to be given up to actually generate any value? And then are guide rails the answer, or are there what is your human factor and also your technological factor to drive trust?
Yeah, so I guess upfront we definitely have separate environments, and I know it's easy to give lip service to it, but we generally don't use customer data on training and models. And if we're doing experiments on things, you wouldn't copy and paste somebody's bill into Google and expect that it's going to be never intercepted, right? So I wouldn't do that. I don't expect the same thing from my team to be copying and pasting customers' bills and informations into any of these AI models either. So when we're doing things, it's from a technology perspective of understanding how could this be used, and when we actually deploy something. So although we may be using Cursor, or I touched on Codium as well, therefore proof of concept type of things, right? Where previously you could write a product requirement, get a designer in to do a wireframe, mock up a presentation and so on. That process from, idea to proof of concept and look and feel model has been shortened significantly because we can prompt that and get that click-through model very, very quickly. It may not look the greatest. It may not be completely functional code, and that's okay. But we got to a customer communication point faster, a stakeholder communication point faster than we would have otherwise. So picking and choosing where we're using these things, again, we're not using it in LLM models in production because I'm not confident that I can contain the information in there just yet. I'm not confident that it's not going to go somewhere else. It's, who are those trusted parties within our ecosystem? But a machine learning model that I can train locally, run in a contained environment in AWS or Azure has a different trust profile to me, and I can segregate data and make sure that it's all secure. So definitely different maybe maturities of technology or trust, as you said. I mean, again, just hypothetical at the moment, but there's probably different business cases and people leading these at the moment from Anthropic and Google and Gemini, and they have different needs at the moment compared to running a model and training a model locally. So we'll see how the industry matures, I guess.
At the Berkeley Innovation Group, we are a strategy consultancy and AI advisory firm focused on mid-market companies looking to unlock big growth. In contrast to management consultants' typical top-down, hypothesis-driven approach, Big uses a curiosity-inspired, bottom-up approach, leveraging customer insights to drive strategy co-creation. Learn more about our approach by downloading our ebook at biginnovates.com/ebook. Now, back to the show.
Welcome back, everyone. Talking to James and really touched on some very interesting pieces. Just at a very high level, we talked a lot about the energy markets on this podcast earlier, so I won't take too much time in that. But what we're finding is this critical link as energy demand increases is the balance between supply and demand, especially in those critical moments. And we've gotten into kind of their solution and peeled back the onion a little bit down to the role that AI and ML play in their solution. And so, James, I want to pick up the conversation here with this idea of, for executives who may be concerned that, well, AI is going to take my data to improve the LLM. On the other hand, machine learning, I'm hearing you say, is actually better in terms of protecting data, but can actually give you as robust of solutions depending on the application. Tell us a little bit more about how you look at that, especially dealing with sensitive information like your client's data.
Yeah, so I guess the difference from the technologies is with an LLM, it's running the model locally versus using a third-party application. Right? So being able to download a Llama model or a DeepSeek type model, running it on your computer, it's already trained, and I put my data in and a prompt and something comes out the other end, that should be contained. I should be able to run on my computer or my server, as opposed to putting something into Google Gemini or Anthropic Claude, or being able to, where that extra layer on top is using like a search engine and taking my prompt, reviewing the data, reviewing my responses to then put that into future models. So separating when we train a machine learning model locally or could use a LLM model locally is different to going through a third party. And that's where that extra data may leak.
Perfect example. And I think this is why companies are putting many companies, particularly in regulated industries, are putting such tight guide rails on the individual user is you can't take that back. Once the data has been exposed to that model, you can't take it back. And that becomes the challenge, which sort of leads me to the next topic we wanted to discuss. And that's, how do you build trust with the utilities? Regulated industries, right? Very slow to adopt, et cetera, conservative. How do you get them to accept, hey, we're running this AI-based or machine learning-powered model, and it's actually going to be more effective than me sitting around waiting for a text message from you? Tell me about that conversation, because this is a big headwind a lot of executives talk about, is it's against the industry norms.
Utilities typically move fairly slowly compared to other industries, and I would argue that's in a lot of ways a good thing. Again, as what I just said, we don't necessarily always want to use the latest and greatest technology. We just want our lights to turn on, right? So I think there's definitely a good portion to that, especially when it's very dollars and geographic expensive, to be able to install power lines and so on. So having contained pilots is where utilities can benefit, and there's definitely a lot of pilots out there for data and processing and forecasting, and that's where the role of a startup at some extent is, right? To take these technologies that exist, try them in a different industry and see if something is beneficial or something sticks. As a startup, that's very hard because you either need to raise money and stay alive or sell something that's adjacent to gain a customer base to then hopefully in the future use this cool new technology. And that's the challenge of running a business and a startup. But I would agree that it's not always the utility who should experiment with these, but absolutely the people and the companies on the peripheral, and for utilities to have contained pilots to allow that data sharing or those things to occur and experiment to see what's best for the customers.
A great point. And it brings me back to an analogy from earlier in the conversation, is that the demand game changes at the wall, that exterior wall. And in your opinion, do you find consumers, and I'll lump small businesses into that, as more adoptive of that technology within inside of their four walls? Is it larger Fortune 500s who have maybe had this experience, through other verticals within their business and are bringing that knowledge over? Or is it the utility side? Of those kind of three players, where do you see the most adoption and the most opportunity?
I mean, a little bit of everybody, right? So when we deal with largely, and it's just a trend curve, right? Your adopter curve of, we see some Fortune, 500, 100 companies are definitely more advanced and more experienced than others. So and it can get down to the basics of, one customer is able to shut down their temperatures in the stores by 1 degree, whereas another customer who again is sitting on the same Fortune list, they may be able to react to a real-time notice in 3 different, multiple markets across the country at different threshold levels and so on, distribution centers versus a retail store. But it's taken years for them to get there, that they've put investments into, again, IoT, smart technologies, wireless technologies. They've upgraded their systems along the way. So as they now have done those things, they can see that they have this, for other projects, a back end of billing data, a database of billing data, a database of energy data, which then it's now a startup's role to come in and say, can I give you insight in this? This is the type of thing that you could do with this. It's a sales challenge, and it gets back to that trust challenge, right? How do you start small with a pilot and work your way up to prove your value, or and then get bigger and bigger?
So what are the realized benefits to an end customer of your type of solution?
It could be as simple as just energy savings, right? It could just be, I have a lower energy bill, or I get paid to reduce energy from a demand response mechanism. But for some customers, that's not the only goal. So demand response is another tool, like change your LED light bulbs. Let's enter a DR program. But it could also be the CO2 savings and sustainability goals that customer have. So being able to reduce energy when the grid is dirty, based on a dirty signal, based on a gas peaker plant being on, you get a CO2 reduction as well.
Wow.
So it depends on what the customer wants. Typically, it's financial, again, related to energy savings, but there's also a green and sustainable slant as well that a lot of customers are going to.
That's my experience from being in the industry, is that there's a lot of people that wrap themselves in a green blanket, but at the end of the day, the inside of that blanket's lined with dollars. And
which is real, right? Like at the end of the day, you're running a business, and as I said, you got to make sure why some customers are better than others is because some businesses run better than others, right? So at the end of the day, it's our job to try and maximize revenue, but also do that with as less little tension as possible for those customers, right? So it's take the regulatory rules and put it into a nice service so that customers don't have to deal with utilities, that they have one contact with us. We'll help you. We'll guide you through it. We'll automate it so you don't have to hit the button. You don't need to hire more people. You're just going to get, a pat on the back from your boss at the end of the quarter because you did a good job. And again, always think about the people along the way.
Yeah, but that's a perfect example. And I'm a firm believer that the financial and business incentives that drive green energy adoption are good.
Yeah, absolutely. I mean, you said you worked in solar previously, and I mean, the reason why solar is doing well is because it is cheaper in a lot of areas to install than other technologies. It comes with risk, that there is no sun at the nighttime. We mitigate that through batteries. Batteries are getting cheaper. So inherently, like, there is a commercial aspect to all this, and with scale, we're connected to thousands of sites across the country, and with scale, things become more cost effective for us or for customers to do.
Mm-hmm. Mm-hmm. Well, I want to is there anything else about kind of the technology that we haven't touched on? Because I want to pivot a little bit and talk to your experience as an entrepreneur, but I don't want to leave this conversation if there's anything we haven't covered.
No, I mean, just the last one. I mean, AI is a tool. We've talked about it within energy, but we use it for prototyping. We used it for templating, requirements writing, writing test code as test case as well, unit tests, integration tests. Again, it's a pretty good tool to be using for those base test cases, and then once you get into the more business logic edge cases, that's where the people come in. But it definitely makes a senior person be pair programming faster with a junior person in respect of an LLM model or some kind. So I definitely think AI has its place in industry, business specific, but also as a tool across the organization too. Just understanding, like anything, the pros and cons and what you're giving up or leaking out at times too.
So this brings up an interesting point that I'm talking about. Later this month, I'm going to be interviewing the CEO of Bolt, and they're the coding company. And one of his visions is that the risk is to the junior coder, because we're actually going to see PMs being able to do this software development themselves, or that initial software development themselves. So turning away from your product and more to your internal operations, how do you see AI and machine learning improving, just streamlining your processes?
So, if you look at, it's very easy to be impressed by videos and photos, image generated online. And I look at them, I'm not an expert in that field, and I look at it and think, these are impressive. Even the difference from a year or two that Will Smith eating spaghetti video, right? It looked terrible, but at the time it was quite impressive, and it got better. Coding and energy things that I'm looking at is very similar. That it is the code that comes out definitely feels like a junior person had coded it, right? But it got us to somewhere faster, and this wasn't possible a year ago, 2 years ago. So it definitely has a lot of tailwinds behind it, a lot of money and investment behind it. So I imagine in a year or two we get into a better spot. But I think about this often, and that's one view, but I think about it from, you mentioned the PM view or the management view. One of the benefits that I still see by having an expert or even a junior person in the room is I talk to somebody, I give them a task, and that's fine. you'll think about that. But it's that they go away and do it for a period of time. It's giving me time to think. Or so if I'm asking an AI to do something, that implies I need the task done right now, or I have time to think about the answer right now or act on it now, which often I don't. I'm giving a task because it needs to be done in 2 weeks. And that immediate context, I think that thinking time, that, background information, letting something, dwell in the back of your mind, I think is something that gets lost as we expect AI to give us an answer now, but actually don't have time for the answer now. So I think that's something that hasn't really been discussed in the industry or as a tool that I've seen commented. And it's something that weighs on my mind, as a manager.
There's something beautiful that happens in that time where it allows creativity to thrive.
Yep.
Or those unusual solutions to come about just because of learned experiences or lived experiences, rather than just always having the right answer. That I found it to be fatiguing, if you will, because in our minds we can't process. Some of it is meant to be lost, right? And that's information that's going to be iterated upon and approved. And so it's okay if I don't get it the first time. And clearly you'd probably have some AI enthusiasts tell you, great, well then if you can't process all that data, we'll get you out of the way and put another algorithm in your place. But I'm not convinced on the machine takeover just yet.
Not yet, but in the future, if they are coming on, a big advocate for them and happy that they're our overlords, I'm on the good side.
You're the first person on this show, although I've had many conversations in private with people about, speculating, are we on the good side of the overlords or not? But
I'm on the AI podcast as a big advocate for them. So hopefully they process this in the future and look kindly on me.
Yeah. Brilliant. Well, again, if we could just take a minute and kind of spend a little bit of time on your entrepreneurial journey, because I'm a big fan of I've seen this movie before, right? Presented with a new situation. And from a commercial perspective, at least here in Silicon Valley, I can tell you this boom in AI, the AI cycle is very reminiscent of that boom in the dot-com bubble 30 years ago at this point. And so again, I'm not saying it's apples to apples, but it walks like a duck and quacks like a duck. So with that being said, like, what have you seen in your entrepreneurial journey? What are the lessons that you've learned that you've seen come back around and maybe harboring on truisms as you've gone on this journey?
As we touched on it, I agree with you. Like, this is in an adopter curve type of cycle, right? I'm not sure we've hit the top of the hype cycle necessarily. There's definitely some cool things happening, a lot of investment, a lot of exciting things. Often when you chat to AI or machine learning companies and, to partner, or you go to a conference and there's a showcase of some companies there. And once you get behind the scenes, it still is a bunch of people with spreadsheets, trying to piece things together. So I'm always very skeptical on AI. But as we touched on, nobody talks about machine learning anymore. And if I go back, 15, 20 years, machine learning was all the hype in IoT, and we now have access to all this democratized data. But now it's disappeared because it's a boring technology, but it's probably at that resurgent, or, what are those boring technologies in AI that allow that to find its time to take off as the adult in the room. So, yeah, as I said, it's okay to experiment. It's okay to be up to date with the latest technologies, but not everything, not everything needs a blockchain, right? Not everything needs an AI model attached to it. And sometimes you just need a good customer communication channel.
And I would add to that, not everything needs an app.
Yeah.
It's true. I tell my students who always went back when everyone was pitching apps, I said, there's only so much real estate on your home screen of your phone. You may have the greatest app in the world, but if my home screen's already full, you're out of luck. And it's similar to this. Is so many of the initial forays into AI were just wrappers on LLMs. And when I see that, I always ask, well, what's the risk that this becomes a feature of the bigger model?
So the wrapping of the LLM, I actually think, is an interesting idea. That there's been a huge rush and billions, if not trillions of dollars, of people trying to get the greatest model, the greatest LLM interface. But that seems to be going the way of MCP and APIs and so on, that you can sub out models. So where there will be your Google and others who end up owning the greatest model, it still gets back to the customer value of what are you doing that's on top of that model. So next year when something better comes out, you had customer attention because somebody likes your, takes a photo of your food and does a nutritional breakdown of it through AI camera, right? Which has been a really pivotal app that's come out recently. People going for the app and the experience, not for the AI technology underneath. So like always, watch your customer, what channel are you talking to them in, what's the stickiness thing, and what value you're creating to get that stickiness. Gets down to the product, not necessarily the technology.
I heard you talk a lot about in design thinking, we always start with desirability, the needs of the user before we get to the feasibility or the viability. And when you look at the business model canvas and you overlay that definition, it's that upper right quadrant of who's your customer, what is their relationship to your value proposition, and then how does that value proposition back to the customer in terms of the marketing channel. And that's your flywheel.
Yep.
And nowhere in that flywheel is a bigger server.
No, absolutely. And I mean, it could be it's a faster response time, which becomes a bigger server, but it became a bigger server because it was easier and faster for me just to get to the next tier of my database than invest 6 months of dev time. So as I've gone through my engineering career, I guess in talking through entrepreneurial, I always wanted to build the latest and greatest thing, and that's why you get into engineering, to build cool things, right? But I get more satisfaction from happy customers and again, it's easy to give lip service to this, but a happy customer or a successful release and people are using your thing rather than it sitting on a shelf and I built this cool thing, but no one's using it. So,
Right.
Find, as you said, what's desirable for a customer, why they're coming back.
Yeah. And so in your taking that back to, Enersponse, it's that idea of your customers, yes, they want savings, but underneath that, those savings have to be backed by trust.
Yeah.
And that's how you know that it's sustainable. So in reality, anyone that's involved in turning the light switch on and getting those electrons to the bulb to give you light, they're in a trust business.
Yep. And we're in a trust business, not just on we're going to give you savings, but we're not going to, because we're shutting things down or reducing temperatures, we're not going to disrupt your business in doing that, right? A grocery store isn't going to shut down their freezers and spoil food. It's a genuine use case. A Denny's isn't going to adjust their thermostats so that people aren't going to come in on a Sunday to get away from because they don't have AC, right? So it's making sure that the lighting doesn't go off and the product looks good on the shelf. So trust is me and the customer, but in the business I'm in, it's making sure my customers are also happy that I'm not disrupting their business as well. So it comes in a lot of areas.
And just, I asked this question because I teach a class in the engineering school, and I always try and impart this on the future engineers, but they're so driven that their value is in the quantitative abilities. But these qualitative abilities, particularly as you rise the ranks and take on more of a business purview or a business responsibility in the business, you have to understand this qualitative piece and the needs of customers.
Absolutely. So you still, as I've gone through my career, you still need to understand the dollars and cents quantitatively.
Yeah.
But qualitatively, we're going after an energy market. What does that mean for my customers? Do I have customers there? Are they going to be happy about it? There's a new program. We shut things down or, curtail energy from 1 hour to 6 hours. Can customers turn off their heating cooling for 6 hours? Probably not. You could shut down a pump for 6 hours. So what does that mean for that end customer? Then does the dollars and cents match? Because I'm going to get customers to come into that is where the quantitative steps in as well.
Well, let's bring this conversation home. And let me just ask you, so what's next for Enersponse?
As you mentioned, as data centers come in and people are building, everyone wants more energy. So demand response is absolutely the fastest way that a utility can connect to a customer and reduce energy and make the best use of the energy that they have today without waiting for 5-10 years for a plant or something to be built. We can have something up and running in literally weeks. Wow. The best demand response is better and different regulatory structures. It's more different tariffs that allow this in a cost beneficial way for us and customers to participate. And more automation along the way to allow customers to be able to react in faster and faster or more grid sensitive times.
And particularly on the last point, having that machine learning or AI back behind under the hood, if you will, is what's going to be a true differentiator. And you're clearly doing that. So, James, this has just been fascinating. It's been a real wandering conversation. But as I say, the goal of this podcast, you should walk away like, wow, that was just a great hour coffee that we had. And I feel like we had a great hour coffee. So thank you for taking the time to chat.
Yeah, thank you. And thanks for having me and having these cool technology conversations. It's great.
Cool. And so tell us a little bit more about where folks can learn about, just follow you and also learn about what Enersponse is up to.
Yeah, so all our normal social channels, Enersponse is on LinkedIn. We have a website, as well as, I'm also on LinkedIn as Jay Muraca, or on Twitter. I don't really post very much, but I'm there too. So,
well, we'll certainly put your LinkedIn profile in the show notes, and then of course Enersponse as well, and folks can follow up there. But thank you again for being so generous with your time and just taking us on this really interesting journey.
You too. Thank you.